Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication at MLR Institute of Technology. Today's video is branch instructions of 8086 microprocessor. This video is a part of series microprocessors and microcontrollers. The overview of today's presentation is what are branch instructions. There are two types of branch instructions, and what is unconditional branch instructions, conditional branch instructions, what are the loop instructions present in 8086, and what are the applications of these instructions in real time. So coming to the branch instructions, these are the instructions which alter the execution or flow of the program. So some of the examples of branch instructions are jump instructions, jump if carry is there, jump if no carry is there, jump if zero flag is enabled. Those all are the instructions which is present in the branch instructions. Coming to the types of branch instructions, there are two types of branch instructions, unconditional branch instructions and conditional branch instructions. We're coming to the unconditional branch instructions. These are the instructions which transfer the data to the other address location, or control is transferred to the other instruction without having any condition over the instruction. So such type of instructions are called unconditional branch instructions. Here jump, JMP, jump instruction is the unconditional, where the control of control of the program will transfer to the other instruction without any condition. If there is any condition, if that condition satisfies, then only the data, the transfer program will be executed at that particular condition, if condition is satisfied. Such type of instructions are known as conditional branch instructions. One of the example is JNZ, jump if not zero, or jump if carry is there, jump if no carry is there. In comparison instructions, if jump not equal or jump if equal, such type of instructions are there. We will see in the further slides. So coming to the unconditional branch instructions, one of the most important unconditional branch instruction is jump, JMP, which is the unconditional instruction. So this the control of transfer will be moved to the other location without any condition. Let us consider one example here. So here I have already what it will, the contents of the immediate data 1, 2, 3, 4 will be moved to the AX register. Now the AX register is having the data 1, 2, 3, 4 H, and next without any condition we are just mentioning that jump, JMP. So the control will be moved to the location where here I have specified the label. Next is the label. So it will changes to the instruction where next label is present. So here next label is present. Now what will it do? That normally the execution of program will be like this, one instruction after another instruction, but by using these branch instructions the control will be transferred to the other location. Here I am using the jump instruction, so jump to the next label. So it will find the label next in the program, and the control will be moved to this instruction. So what the after this instruction, the instruction will execute is move BX comma AX. So the data present in AX register will be copied to the BX register. So this is the transfer of control without any condition. Here I didn't mention any condition after satisfying this transfer to that particular location. No, I didn't give such type of instruction. Here I just mentioned the jump instruction, so the control will be moved to the label which I have mentioned after jump instruction. Here you can also mention the address of a particular SI and DI locations. So coming to the next instruction, these are the instructions very important in 8086 microprocessor. So here the instructions are call and return. So call instruction specifically is used for the subroutines or subprograms. See, if we are designing any website, so authentication is needed to get into the, suppose let us consider one example of Facebook. If we want to log in into the Facebook, we need to authenticate with the ID or the password. So every time we want to log in, so if we want to log in, the authentication page will be set as subroutine. So if whenever we need to access the authentication page, we can access that subprogram or subroutine. So subroutines and subprograms are very important. So we need not to write it again and again. We just write the set of instructions in that particular subroutine, and we can call the subroutine whenever we needed in the main program. So here call and return instructions are used to call the subprogram from the main memory, and a return instruction is used to get back to the main program from the subprogram. So let us see one example over here. So here I was taking as moves 2, so which here represent as 0 2h. So in this instruction, the AX register is filled with the data 0 2h. Now I was directly mentioning call instruction. So call square. So the difference between the jump instruction and call instruction is, when we are using jump instruction, the data will be, the control will be moved to the instruction next, and here if any another instruction is there, this instruction will get executed. But coming to the call instruction, call is a calling the subprogram. Here the subprogram label is square. So call instruction will fetch the instructions from the subprogram. So here it will move to the cursor, transfer will be over here, and it will execute mul AX. So the AX will be get multiplicated with the AX register itself. So 0 2 multiplication with 0 2, the output will also be stored as the, because here for multiplication instruction, so the destination operand will also be the accumulator register itself. So here we are using the square of, we are finding the number square. So after this instruction, we got the output as AX equals to 04H, and here return instruction is mentioned. So whenever we need to get back to the main program, we need to write the return instruction. So return indicates that the main subprogram has ended and we are getting back to the main program. So after that, what is the instruction? Halt. Halt is the machine control instruction which will end the program itself. So this is the example of call and return instructions. So coming to the another set of unconditional branch instructions are nothing but the interrupt instructions. So I have already mentioned that interrupt, I have already done the video on how interrupts are executed, interrupt service routine, how we will get back to the main program, and how processor will approach the interrupt when it is enabled, and where the addresses of these particular interrupts have been stored. All these are I have already explained in the previous video. If anyone didn't watch that video, do watch that video. So coming to these instructions, here int n. So I already mentioned that we are having 256 software interrupts in 8086 microprocessor. To enable one of the interrupts, so we can use int. Interrupt 21H is the interrupt number. So if we are executing any program, if the processor is encounter the interrupt like this interrupt instruction, then it pushes the CS code segment value into the stack and instruction pointer value into the stack, and all the flag registers, all the values of flag registers into the stack. So then it will jump to that particular location. How it will jump to the particular location? Whenever the processor finds this interrupt instruction, then it will get to the interrupt vector table to find the address of that particular instruction, particular interrupt. Here we have mentioned the 21H interrupt. So it will get to the vector table and it find the address of that particular interrupt, and then it jumps to the interrupt routine. So in interrupt 21H, some sort of program will be there. After that, return I return will be there. So this is the interrupt return instruction which use it like the interrupt return equation, but here it is telling that get back to the main program from the interrupt, return from the interrupt. So whenever the processor finds this return instruction interrupt, then it will get back to the main program and execute the next instruction. Here LEA means load effective address. Here I was storing the hello world string into the message label, and this message label I need to display this hello world in this program. So I was loading the address of this particular label into the DX register. So now these two are the interrupts which is used to execute the display, which is used to display the string which we are present. So mood AH,09H is the DOS interrupt which is used to execute the whole string. So that DOS interrupt followed by int21H interrupt, then only this in whatever the string we have mentioning in the program will get executed, and in the console we can see the hello world. So coming to the next interrupt, I have already told you this instruction iReturn. iReturn is the instruction which is getting back from the interrupt program to the main program. So whenever the processor finds this iInterrupt instruction, it will restore the values from the stack to the main processor because it needs to execute the current main program. So this is the iReturn interrupt instruction. So coming to the conditional branch instructions, there are number of conditional branch instructions. Here jump equal or jump 0. So it will check whether the 0 flag is 1. If the 0 flag is 1, then this condition will get satisfied and it will jump to that particular label which we have mentioned in that particular instruction. So some of these examples of conditional branch instructions are jump if not equal or jump if not 0, jump if greater or jump if not lesser or equal, which is all equals to jump if greater. So next, jump if lesser or jump if not greater or equal, jump if greater or equal, jump if not lesser, jump if lesser or equal, jump if not greater, jump if overflow flag is set, jump if carry is set, jump if not carry is there, jump if parity is even or jump if parity is there, jump if no parity, like jump if odd parity, jump if sign bit is enabled, jump if no sign bit is enabled. These all are the instructions which is present in the conditional branch instructions. Let us see some examples of these branch instructions also. So coming to the JG, which is nothing but jump if greater. Whenever the processor finds this instruction, encounters this instruction, first it will check the flag register of 0. If the flag register is equals to 0, then it can execute the instruction itself. Or if SF, sign flag, is equals to the overflow flag, it will check these two conditions. If these two conditions is here satisfied, then only the control will be moved to the label which we have mentioned in the instruction JZ. So here the data present in the AL register is 05H and here the data present in the BL register is 03H. When comparison operation is carried, then the comparison instruction will execute the subtraction between the destination operand minus source operand. Here the destination operand is AL and the source operand is BL. So 5 minus 2, answer is 2. So there is no 0 flag because the answer is not 0, sign flag is equals to 0. So yes, JG satisfies and the control will be moved to the greater label. Here the greater label is here. So what it is mentioning, so the DX, if this condition satisfies, then only the DX register will get 1H, 01H. If the condition doesn't satisfy, it will move to the other instruction, next instruction. The control will be transferred to the, if the condition satisfied, then only the control moved to the location which we have specified in the instruction. If condition doesn't satisfy, the execution will be moved to the other next instruction present in the program. So this is how jump if greater instruction will work. Like on jump on carry. If carry is present, then only the instruction will, the condition will, if condition satisfied, then only the transfer will move to the label which we are present in that particular instruction. Let's see the example here. If here the AL register is filled with the data F8H and BL register with 02H. So whenever we are adding these two registers, what will be the output if F8 is added to the 8 plus 2 is 10. Here we are mentioning in the hexadecimal number. So A. So now coming to the F is 15 and 3 is, if we add 3 to the F, which we will get 18. But here this 18 is the decimal number, but we need to mention here in the format of hexadecimal number. So 18 will be represented as 1 with 2 in the hexadecimal number. So 2 with carry. Now see, here we are getting the carry flag. Carry equals to 1. While performing these 2 instructions after addition program, after addition instruction, we are getting the carry as 1. So here what I have written, jump if carry. Yes, jump if carry to the location carry occurs. This is the label I have given as the label. So this is the, so when carry is there, so while we are checking, yes, carry flag is enabled. Now the transfer will be moved to the label carry occurs. So hence it will move to the, after jump instruction, it will get back to the. So these 2 instructions will never get executed in this particular program. Okay. So now coming to what it will do. So next, the output DX register will fill it with the 0-1 data. So next, halt. So this is how the conditional or unconditional branch of instructions will work. Next, coming to the loop instructions. So the main instruction in the loop is LOOP, loop instruction. Here, while using this loop instruction, how many times we need to repeat such type of instruction? So this particular set of instructions will be repeated until the condition satisfied. So this block of code which we are writing in the particular loop will get executed until CX register will get 0. So the count in this particular type of programs, we need to mention the count in CX register. See, let us see the example of a loop instruction. So here move CX register is loaded with 3. So when this loops executed until CX register will get 0 or the condition it satisfies. So now CX equals to 3. Now what we will do, add AX comma BX. If any data is there, so addition program will perform addition operation will get satisfied with this instruction AX plus BX and the output will be stored in AX. So what I have wrote, loop start. So again it will get back to the start label without, but before going to the start label, the CX register will automatically decremented by 1. So already we have said it 3. So it will decrement to 2. It will check if CX equals to 0, the loop ends there itself. But the CX is not 0, it is 2. So again the loop will get back to start label. So again AX and BX will perform execution. Next again, while coming to the loop start, it will decrement the CX register by 1. So here we are getting 1 only. So again the loop will get executed until next it will become 0. So whenever the processor encounters 0 in the CX register, then the loop ends there itself. So this is the difference between the loop and branch or conditional branch instructions. So how these, what are the applications of these instructions? When coming to the unconditional branch instructions, it will jump over the sections of code and it will infinite loop and function calls will be executed by using unconditional branch instructions. So while coming to the conditional branch instructions, these are the instructions which depends upon the decision making or conditional logic. If this condition satisfies, then only do this particular thing, or else get back to the main program. So such type of in such particular applications, we can use conditional branch instructions. When this particular set of instructions need to execute unlimitedly or needs to execute this particular number of times, then we can use loop instructions. So until now, I have discussed what are the branch instructions present in the microprocessor of 8086 and these conditional and unconditional branch instructions, and coming to the loop instructions and what are the applications based on these instructions. Thank you.